Alright, welcome back, Algebra 1, to my favorite notebook. So last week you did word problems 1 through 6 and you created tables. So this is my example of the tables. And what I'm trying to do is wrap up what you did last week and trying to find patterns. The thing I love about math is it's always trying to find patterns. So last week I asked you to think about the rate of change. So last week I asked you to think about the rate of change and the starting point. So last assignment I said every time you do this, think about the rate of change, how does it show up, and the starting point. So you started out today with a Desmos and you typed in your numbers and it gave you points on a graph. Right? So with those points, I was hoping that you would see that the starting point is there. So that's your starting point. Right? And then in your table, as you go down, you'll notice that your rate of change is what that is. So the rate of change, how much this goes down, is your rate of change. Okay? So with the movie theater passes, it started at a number and it kept going, right? But with the regular pass, so it just kept going in that direction. With the regular pass, it started at 0, but it was steeper. It went at a faster rate, right? So this is your starting point, and then this is your rate. Well, on this one, the rate was 1. So your rate equaled $1 per movie. So for every dollar, so for every movie, you went up $1. So up, over. That was what happened. Whereas on the regular movie theater, what happened is you went up $3 for every one movie. One movie over, $3 up. So once again, your starting point is where it crosses your y-axis, and your rate of change is how much it changes. So this went down half a foot for each day. So every day you go over, it dropped down half a foot. So down a day, down a day. So on these, when you go by one number every time, this is going up 1. With this one, you're going up $3 every time. If I were to skip these numbers, if I were to go by 2s all of a sudden, this would go up by 7, but that would go up by 2. 7 divided by 2 equals my $3.50 per one day. So anytime that you have a table and you're checking those relationships, you're checking them on both sides. So yeah, that change happened over how many movies. So that always shows up. It may look different from time to time, but that's where the attention to detail shows up. So once again, I took a jump $10 there, but over here I took a jump for 2 hours. That 10 divided by 2 is going to get me back to my $5 rate of change. Same thing down here, where right here I jumped $100. But that rate of change also jumped $2. So that 100 divided by that 2 gave me my $50 per hour. So per is always on the bottom. So going back to your water level, your X value was the days. Going back to the movie passes, your X value was the movies. Going back to babysitting and plumbing, your X value were your hours. Right? So X usually is always time, and it controls the other thing. So your hours of a plumber control the cost. Hours of a babysitter control the price. The number of movies controls the cost. And the number of days controls the water level. So I also asked you to think about this, because we were talking about domain and range. So the number of days only makes sense from when you had the water the first day to the last day. So this point is at 68.0. So this is when your water level is 0. It doesn't make sense to have a negative water level. Cool? Also, looking at your rate of change and your starting point, you'll notice that in all your equations, your rate of change goes with your variable, and then your starting point is at the end. That rate of change, another word for it is slope. And that starting point, another name for it is your y-intercept. So you'll notice that when you have a movie pass, the rate of change is 1x. It goes up by $1 for every movie you go to, plus the $40 in the first place. Another way to write that is x plus 40, where 1 is your slope and 40 is your y-intercept. Y equals 3.5x. This is your rate of change, is your slope. And you'll notice that if you don't have anything back here, you start at the origin. Because if you have 0 movies, if you go to 0 movies, you have 0 costs. So if you don't see anything, it's at the origin. Also, you'll notice that when you plotted your points on the decimals activity, that this line was shallow compared to this line being steep. These are words from your vocab that are going to be coming up. So throughout the unit, I'll be going over those vocab terms. So if you didn't rock it out on the first quiz, don't worry about it. You get 3 attempts. Babysitting had a starting point of $3, and then it went up $5. So compared to this $3.50, this is even steeper. So how quick that rate of change goes tells you how steep or shallow it is. And this one was y equals 5x, $5 per hour, plus the $3 flat fee. So every time it says each, every, per, that's going to be your rate of change or your slope. And that starting point is your y-intercept. And that intercept is important because that's where it crosses the y-axis. This one was like 25, 50. Y equaled, it went up 50 per hour plus the 25 starter fee. So this is a wrap up of word problems numbers 1 through 6. I did not do them all, and I tried not to do all the numbers you had, but every time you look at it, your rate of change shows up on the difference on your table compared to your X. So if it goes up by 1 over here and 1 over there, if it goes up by 1 over here, that's your rate of change. But if it goes up by 2 over here, you're going to have to divide that change to see how much for 1 unit. So anytime you get lost on slope, because I know it's tricky, this is a great example. So let's go, Truman.